Hi, question number 4. We have matrix A, B, and C. We need to show that C times AB is equal to 3 minus 7 minus 9, 3 given those matrices. So basically what we're going to do now is we're just going to multiply A to B. So A here multiplied by B. This is what we get. And now what we are going to do is we're just going to take C multiplied by the result of AB. So let's push this a little bit up here. And therefore we have minus 2 times minus 2 is plus 4, minus 1 times minus 1 is plus 1, 1 times minus 2, 4 plus 1 is 5, 1 times minus 2 is minus 2, minus 2 plus 5 is 3. Then we've got minus 2 times 4 is minus 8, minus 2 times minus 1 times minus 1 is plus 1, minus 8 plus 1 is minus 7, 1 times 0 is 0, 0 plus minus 7 is minus 7. Then we've got 1 times minus 2 is minus 2, 1 times minus 1 is minus 1, 3 times minus 2 is minus 6, minus 2 minus 1 minus 6 is minus 9. And also we've got now 1 times 4 is 4, 1 times minus 1 is minus 1, 4 plus minus 1 is 3, 3 times 0 is 0, 0 plus 3 is 3. As can be seen, now this has been shown because this is exactly the same as this matrix over here. Moving on to the second part of the question, we need to find the equations of the invariant lines through the origin of the transformation in the xy plane represented by CAB. Now then, to do this, we can take the matrix CAB, which is over here, and then we multiply it by xy, and we equate it to, let's say, x1 and then x prime and y prime. And doing so, it's going to result into 3x minus 7y is equal to x1, x prime. Then we have minus 9x, okay, and then 3 times y is 3y, so plus 3y is going to give us y prime. We also understand that the equation of a straight line over here, we're talking about the equation of the invariant line is y is equal to mx plus c. So what I'm going to do right now is just going to substitute this into those equations. So the first one is 3x, okay, minus 7 times y, and y is mx plus c, so we've got mx plus c, and that should be equal to x prime. We also have minus 9x plus 3 times y, and again it is y is equal to mx plus c, and that should be equal to y prime. And when we look at this now, so let's try and understand what we should do. Now we've got the y prime over here, but I want to expand this. So we've got x here, so the x can come out, and I've got 3 in brackets minus 7 times m, which is minus 7m. Then minus 7 times c is minus 7c. And all of that should be equal to x prime. Right here, I've got negative 9, and if I were to factor, let me see, okay, so minus 9, let's try and put the x outside anyway, so minus 9, okay, into 3 times m is plus 3m, and the x is outside. Then minus 3 times c is plus 3c. And all of that should be equal to y prime, which is on the same invariant line, mx plus c here. So I'm going to say then y, which is mx plus c. So if I look at this equation here now, I've got x into minus 9 plus 3m plus the 3c is equal to mx, and because x is all of that over here, which is x prime, so we have then x into 3 minus 7m, okay, minus the 7c, and of course plus the c. So what we have then is coefficient of x here turns out to be minus 9 plus 3m, and the coefficient of x over here turns out to be m into 3 minus 7m. And of course now we've got negative 9 plus 3m is equal to 3m minus 7m to the square. So what we're saying is the 3m and the 3m can disappear, and I have then 7m to the square is equal to 9, and so m is going to be equal to plus or minus the square root of 9 over 7, which is then plus or minus 3 over root of 7. Now at the same time, we also understand that it was going to pass through the origin from the question. It says here through the origin, meaning that c is going to be equal to 0. And because the line is the form y is equal to mx plus c, so that's y is equal to mx plus c. We have then y is equal to m, which is minus 3 over root of 7x plus the c, c0, or I have y is equal to 3 over root of 7 times x plus the c, and the c again is 0. So we have equations of two lines, and those are the two invariant lines. The third part of the question, we need to give full details of the transformation by m. When we look at this transformation over here, we have 3, 0, 0, 1. We can test this through the unit square. Let's say this is 1, 1, and if I were to multiply this by 1, 1 over here, it's going to turn out to be 3 and then 1. So this comes here 3, and it looks like a stretch to me. Okay, so this is a stretch, and it is a stretch which is parallel to the x-axis. Stretch parallel to the x-axis with stretch factor or scale factor 3. And basically it's a one-way stretch. We need to find the matrix n such that nm is equal to CAB. Now this is nm is equal to CAB. Now we also need to find this matrix n here, so n is going to be equal to CAB multiplied by the inverse of m. So we're going to get all the information here. Now this is what we have, and this is the matrix M here, and if I want to find its inverse, so M inverse is going to be equal to 1 over its determinant. The determinant turns out to be 3 minus 1, which is then, 3 minus 0, and so 1 over 3 into then 1, 3, 0, 0. So we're going to multiply this by 1, 0, 3. And then the 1/3 can come here, so I've got matrix n. 3 times 1 is 3, 7 times 0 is, minus 7 times 0 is minus 7, so that's going to be 3, and 3 times 0 is 0, minus 7 times 3 is minus 21, and also I have minus 9 times 1 is minus 9, 3 times 0 is 0, 0 plus minus 9 is minus 9, 3 times 3 is 9. So if we divide all of that by 3, this is what we get. We get 1 here, minus 7, and then minus 3, and then 3. Okay, so this is the third part to this question. 3 marks there. Well, take care.